In 2013, scientists made a measurement that should have been impossible. They found a star that's older than the universe itself. Not by a little, by 600 million years. Its name is HD 140283, and for over a decade, it's been astronomy's most awkward secret. Because if this star is right, then everything we know about the Big Bang might be wrong. In 2013, scientists made a measurement that should have been impossible. They found a star that's older than the universe itself. Not by a little, by 600 million years. Its name is HD 140283, and for over a decade, it's been astronomy's most awkward secret. Because if this star is right, then everything we know about the Big Bang might be wrong. The universe? 13.8 billion years old. You see the problem? This star appears to be 600 million years older than the Big Bang itself, which should be as impossible as finding your birth certificate dated before your parents were born. Here's why this isn't just a measurement error. Stars don't just pop into existence, they need materials. After the Big Bang, the universe was just hydrogen and helium. The first stars formed from that primordial gas. We call them population 3 stars. They lived, died, and exploded. Those explosions scattered heavier elements into space: carbon, oxygen, iron. Those elements became the second generation of stars. HD 140283 is one of those second-generation stars. We know because it contains trace amounts of heavier elements. Not much, but they're there, which means it needed earlier stars to die first. That takes time, hundreds of millions of years. But according to its age, there wasn't enough time. The timeline doesn't fit. It's like finding a smartphone in a Viking burial mound. The technology requires a history that shouldn't exist yet.
Obviously, astronomers didn't just accept this. They did what scientists do. Checked, rechecked, triple-checked. They thought maybe the distance was wrong. If HD 140283 was closer or farther than measured, the age calculation would change. So they measured again, more precisely. The age barely budged. They updated their stellar models, accounted for new data on cosmic expansion, refined the measurements of the universe's age itself. And here's what they found. With error margins included, the star's age is now calculated at 14.27 billion years, plus or minus 800 million years. That overlap technically allows it to be younger than the universe. Barely. Like by the skin of its teeth barely. But here's what no one says out loud. Those error bars are generous. And even with them, this star is pushing right up against the edge of possibility. So what's actually going on? There are 3 real possibilities. Maybe our distance calculations are off. Maybe stellar evolution models have blind spots. Maybe there's something weird about this specific star's chemistry that throws off our age estimates. This is the safe answer, the one that doesn't break physics. But it's also the boring one, and it doesn't explain why this keeps happening with multiple ancient stars. What if the Big Bang happened earlier than 13.8 billion years ago? Even a few hundred million years would solve the problem. This could happen if dark energy behaved differently in the early universe. Cosmic expansion rates were miscalculated. Our measurements of distant supernovae are slightly off. Some cosmologists think the universe could be as old as 14.5 billion years. That would make HD 140283 young by comparison. But it would also mean rewriting textbooks and recalculating the age of everything. This is the wildest option. What if the Big Bang was just a transition, not a creation event? What if the universe existed before in some other form? A previous cycle, a quantum fluctuation, a collapsing predecessor. If that's true, then stars like HD 140283 could be remnants from before our current cosmic era, survivors of an earlier universe. This isn't fringe science, by the way. Cyclic cosmology models are explored by serious physicists, and HD 140283 might be the first evidence that they're right. You might be thinking, okay, cool cosmic mystery, but why should I care? Here's why. Science doesn't progress when everything makes sense. It progresses when something breaks. When Mercury's orbit didn't match Newton's predictions, we got Einstein's relativity. When atoms emitted light in weird patterns, we got quantum mechanics. Every time reality disagreed with our theories, reality won, and we got smarter. HD 140283 is reality disagreeing with us right now, quietly, persistently. It's a 14 billion-year-old alarm clock saying, hey, you're missing something. And whatever we're missing, it's big. Think about what this star has witnessed. If it really is as old as we think, it formed when the universe was an infant, before the Milky Way existed, before Earth, before the Sun, before everything you've ever known. It's been burning for longer than galaxies have had spiral arms. It watched the cosmos grow up around it. And now, it's still here, an ancient lighthouse in the dark, shining with photons that left its surface before humans existed, before dinosaurs, before bacteria. And those photons are telling us, your story is incomplete. How incredible is that? So where do things stand today? The scientific consensus is HD 140283 is probably not older than the universe. The measurements, when carefully refined, seem to just barely fit, but the discomfort remains. New studies keep probing it. Better telescopes, like the James Webb Space Telescope, are taking another look. And here's the thing, even if this specific star gets explained away, the question it raised won't disappear. Are there other ancient objects we haven't found yet? Are our cosmic age measurements really that precise? How much are we assuming versus knowing? HD 140283 didn't break physics, but it did crack open the door to doubt. And in science, doubt is where discovery begins.